let's start by graphing y equals 2 to the x. Okay? Been there, done that. Took the test. Y equals log base 2 of x. Remember to get the base, shift underscore next to the d. And we can physically see that they're inverses because they reflect across the line y equals x. Okay. So that means my x's and my y's are flipped. So keep that in mind. What is our domain of an exponential function? Oh, it's been like 2 whole days since you've taken the test. Some of you took it yesterday. All real numbers. So the domain of my exponential function is all real numbers. So if I switch my x and my y, my range of my logarithmic functions is all real numbers because my domain gets switched with my range. Hold on to that thought. Additionally, my asymptote of my exponential function is the y-axis. I'm sorry, the x-axis. But in this case, my asymptote is going to be my y. So it's going to be vertical. So it switches from horizontal to vertical because, again, we're switching our x's and our... So it makes sense. Okay? It's not super easy, but it makes sense. All right. So let's take a look at the Z notes. All right. So most of our graphs are going to look like the one on the left. But occasionally, they'll look like the one on the right. So one on the left, my base is positive and it's greater than 1. So as long as my base is bigger than 1, it will increase, albeit quite slowly. It's like snail's pace. The other one, the only time you'll look like this is one of 2 cases. One is if b is between 0 and 1, or if we do something else. So let's do a review. Oh yes, you have seen AHK before, right? So take a moment, circle each one, make some little text boxes, and see if you remember what they do. What does A, H, K, and do? A, H, and K do. Take a look up here, and that's what they do. We've done this, I don't know, at least a dozen times. Okay, so now we have a new function, so we can do numerous transformations. Oh boy. So this reflection across the x-axis, if we take a look up here, that's another way we can get a graph looking like this. So b can still be greater than 0, but if we put a negative in front, it flips it. You think we might see that today? Yeah. Okay. Questions? Done this many, many times. All right. So we have an asymptote. It's a vertical asymptote, so it's always x equals either 0 if it's a y-axis, but if we shift away from the y-axis, left or right, it's going to be x equals whatever h is. Our reference point, 1, 0. If we look at our original graph here, this is 1, 0 because 2 to the 0 power equals. Okay, but again, that shifts as well. So wherever it shifts left or right, we'll shift where that reference point is, specifically x-intercept. We will always, always, always have an x-intercept. Hold on to that thought for the y-intercept. Okay. The other reference point is if we take the base to a specific power. So in other words, well, let's look at this one. Real simple. I'm going to change this into a table. Why are all those undefined? Because they're negative. So why can't we have negatives? Because the asymptote. So.
Whenever you square root or.
Now you're getting too complicated. I'm just going to throw some big old complicated math expressions at you. What's your base? 2 to any number. Will it ever be negative? No. Since our base isn't negative, we can't have negative numbers. So you know what? We're just going to get rid of those. Bye, 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 bye. So we start with 1, 0. And then this one is 2, 1. Because again, remember, this is 2. Log 2, base 2 means 2 to what power is 2? 2 to what power is 2? 1. Okay. So let's take a second look down here. Remember what this means. Log underscore 2 base 2 means 2 to what power is 2? And that's 1. Remember, the logarithm is the exponent. So 2 to this power gives me 1. So if I do something like that's Yeah, let's not do that one. How about 4?
Dos.
Ooh, why does 4 work?
4
Because 2 to the 2 is 4. What's my next number that's going to work? Not 5. 8, okay? Because 2 to the 3rd equals 8. So it's kind of like this. Instead of y equals 2 to the x, this is x equals 2 to the y. So it's more like the x's are dependent on the y's than vice versa. Okay? So this graph right here is the same as y equals log x base 2. Okay? Right. Okie dokie. Don't need you anymore. Oh, pretty.
Pretty color.
Oh, let's erase it. And I don't want the pen anymore. There we go. Okay. So, it's going to be not so bad to do this. We're going to get a little more complicated pretty quickly. Ready? Think you should start?
Domain.
No! Not the domain. The range. Because we always know the range is going to be
Oh, the plus 2.
all real numbers.
Oh, yeah, you're right.
Because it just said that the range of the logarithmic functions is the domain of the exponential ones. So negative infinity to positive infinity every single time. Every single time. Every single time. Every single time. Every single time for logarithmic functions.
So it's just
Every single time. Okay? Alright. For domain, remember we can't have negatives, right?
infinity 2.
So then we go back to domain and we set up this little inequality. X plus 3. Oh, I forgot to record, didn't I? Nope, I didn't. We're being recorded. Hello, recording. Okay, x plus 3 is greater than 0. Solve it. It'll take you all of 10 seconds. Don't say it. Solve it. Solve it. And then we're going to write our answer in interval notation. If you're a little confused, just look up here. That means the domain doesn't start at 0 now. It starts at negative 3. Because right here, remember h is always the opposite of what you see. So if you see a positive 3, h is negative 3, which means move to the left. All right. Let's hold on to end behavior. So now we're going to drop down to asymptote. My asymptote is where my domain starts. It is an equation. It's a vertical line, so it should always be x equals, in this case, x equals negative 3. The rest of it, we're going to let Desmos help us out. So go to Desmos and type in the equation. Y equals, don't do f of x. And if you do multiple f of x's, Desmos gets confused. So y equals log base 8 of x plus 3 plus 2. So let's just get rid of these. We don't need them anymore. Bye-bye. So y equals log underscore 8 x plus 3 close plus 2. And then we're just going to let Desmos help us out here because these have decimal answers. So the x-intercept is negative 2.984, comma 0. Negative 2.984, 0. And my y-intercept right up here at 0.2528. 2.528. My bad. 2. Oopsies. 0. 2.528. All right, let's talk about end behavior. Normally, we go in end behavior to negative infinity and end behavior to positive infinity. But the problem here is I've got this asymptote right here. So it means I can't go to negative infinity. This one's going to be a little different. Okay, I think we may have done these once before. So for end behavior, as we go to the left, we are not going to negative infinity. We are going to negative 3. So as x, come on now, approaches negative 3, take a look at the graph. And I'm not going to make him do a hand one here. We'll export it. It's going to go straight down all the way to negative infinity. So comma, f of x, versus negative infinity. Negative infinity. So let's just move this up a little bit. A little space, make another one here, and copy and paste. Control A, Control C, Control V, and we just need to change just a few things. First of all, when we go to the right, we can go to positive infinity. Get rid of negative 3. Again, it's not going down. It's going up just really slow, so just get rid of that negative. Okay. So at this point, go to Desmos. We're going to export the graph. And just paste it in so we don't have to do it by hand. I told you I wasn't going to make you do too much by hand from this point forward, so don't want to make myself a liar. Where's my graph? Okay, so if you're not off the top of your graph page, just have to move down and then grab it, slide it over, drop it down. I'm going to try to put my asymptote on there close as I can. Look at that. That looks pretty. I'll leave it like that. Okay. Talk on. Got a question, Babs? Nope. Okay. Let's see what happens. Now, I will warn you, Desmos sometimes has issues with asymptotes. And we're going to see that in a problem or two later. So as I go to the left, what happened? What happened? What do you think's happening? It's getting so close to the asymptote, it knows that the function doesn't exist. And it's like, I can't put any more points here. And if I do it slowly, it should say undefined at some point, but sometimes it doesn't pick it up. And if I go down far enough, sometimes it won't even show the graph. So we'll see that a little later. So sometimes Desmos does not graph the logarithm graph.
Graph and doesn't.
All right. Question so far. Range will always be all real numbers. All real numbers. Okay. All right. This one's going to be a little bit different. Try that once. Get as much as you can done in Desmos, and then answer as many of these parts that you can. Okay, so looking at the graph, I can see that this is flipped because of the negative right here. It's going to change a few things. Not a lot, but just a couple things. Remember said, there we go. Range is still negative infinity to positive infinity. So negative infinity to positive infinity. Whose? How about my domain? Where are we starting at? You're arguing for her to throw out your trash? I don't understand that. Matthew, where's my domain?
Your domain?
Yep.
I have it as x is greater than 1.
Okay, another way to write it is 1 to infinity. That is exactly right. Okay. So that means my asymptote has to be at 1. X-intercept? Nah, let's see. Santiago, x-intercept. All I got to do is click on it. Did you put the equation in there? Ooh, so it's not rounding. Let's see why it is exactly 1.1. What's my y value? 0. So 0 equals negative 2 log. Oh, wait. Where's my base?
There's no base.
There's no base?
So it's 10.
It's 10. There's always a base. This is a common logarithm. If I don't put the base in, it is understood to be 10. So I'm going to put that in there right now because we're going to need that in a minute. Okay, I'm going to teach you how to solve logarithmic equations. Just like exponential equations, we have to get the exponential part by itself. Well, same thing for logarithmic. So add the 2. I got 2 equals negative 2 log 10 of x minus 1. What do you think you do next? You have a negative 2 times the log.
Divide the negative.
Divide. So think of the log as being like a variable. So anything attached to log needs to go away. So I got negative 1 equals log 10 of x minus 1. My problem is I still have that log attached. So we need to unhook the log. What did you learn how to do yesterday? Change logarithmic equations into exponential ones. So that's 10 to the negative 1 is equal to x minus 1. Well, 10 to the negative 1 is just 0.1. Oopsies. Don't clear the whole screen. It's got to have an eraser. No eraser!
Just use the light.
Oh, there you go. Weak, weak. Okay. So x minus 1. Brilliant, Matthew. I got to remember that. So add 1, and there's my 1.1. And that's why the x-intercept is 1.1. At some point, do you think you're going to be solving these?
Yeah.
Today, not so much. Next week, I'm going to teach you how to solve logarithmic equations. Oh, yeah. Grown. All right. So, coming back here. Equation, x-intercept. Oopsies. Turn off my pen. There we go. Parentheses, 1.1. And now the big question of the day. What happened to the asymptote? I put it in here. Disappeared. Let's put it back. Come on back, asymptote. What's not going to exist? Why doesn't the y-intercept exist? Because where's the asymptote? On 1. So it doesn't quite make it to the y-axis. So therefore, give me, just one word. N-O-N-E.
No.
Okay, end behavior. As x approaches 1, instead of going down, this time it's going up. So come on, fx approaches infinity. And then if I go to the right, so a little copy and paste action, Control A, Control C, Control V. As x approaches positive infinity, does it go up? Nope, it goes down. Okay. Very, very slowly. So again, we go Desmos, export the graph, download it, back to Jimmy, add media, folder, pop, pop, pop. Doesn't like it when I do that. There we go. Questions? All right, ready for Desmos to make a boo-boo? Here's where Desmos makes a boo-boo. Well, it doesn't make a boo-boo per se, but it'll be perceived as a boo-boo on our part. All right, try this one. See what you can do with it. I think it's this one. No, maybe it's not this one. The next one? I don't know. Maybe it's this one. I don't know. Yep, that's this one. Desmos makes a boo-boo. Take a look. Range, yet again, doesn't change. Negative infinity, positive infinity, all real numbers. So negative infinity to positive infinity. Okay. That's end behavior. I'll move that up. Thank you, sir. All right. Let's hold. So domain. 1 again? Negative 1, because it's the opposite of what we see here. So that means it's going to have a y-intercept. On infinity. As it approaches negative 1, is it going up or going down? It's going down. So let's see. So we're approaching negative 1, and we're going down. Okay.
Cough when you're bored.
I was going to say that is very dramatic. Is it going up?
Yep.
So I can leave that alone, right? Okay. We're going to hold off the x-intercept to last because that's where Desmos makes a boo-boo. Okay, x equals negative 1. My y-intercept, I believe, is okay here. That one's easy. 0, 2, which makes sense because if I put a 0 in here, I get 1. What's 0 plus 1? 1. So this whole thing is going to be 0. Because how do I get a 0? How do I get 1? My exponent has to be 0. Okay, so the logarithm, so this whole business right here is all 0, and that leaves me with a 2. So 0, 2. Hey, Desmos, why don't you help me out and help me find the x-intercept? Desmos talks to you right away. How do we know that's wrong? Oh, we can have negatives. But But where's our asymptote?
Oh, it's
It's -1. It can't be the asymptote and be the intercept at the same time.
Yeah.
Ideas of why Desmos is making this boo-boo?
It's rounding.
It's rounded. Okay? So, I'm going to prove it mathematically, and then we'll see that if we modify Desmos just a little bit, it will give us a proper answer. All right. So, we're going to solve another one. Well, I'm going to solve it, and you're going to watch. So, 0 equals 1/2 log base 10 of x plus 1, and then plus 2. Same process. Move everything to the other side. So, -2 equals 1/2 log base 10 of x plus 1 divided by 1/2, but we don't like divided by negatives or divided by fractions, so we're going to multiply everything through by 2. So that gives me -4 equals log 10 of x plus 1. And then we change it into a exponential, so this is 10 to the -4 power. 10 to the -4 power is a really, really small number. How small? 1 10,000ths. So it's 0.0001. And when I subtract 1 from it, I get, this is my true y-intercept. 9999. But what does Desmos always round to? 3 decimal places. But if I round a 4-digit decimal to 3 decimal places, and my 3-digit decimal to, anyway, the 9's bigger than 5. So that rounds this up, and this up, and this up, and changes the whole thing to a -1. Okay? You got it? Because it's going away now. Here we go. You actually want to type all that out?
Yeah.
I need to learn it now.
Yeah.
If you won't let me type it out now, I'll do it
Well,
later.
it's going on to the video.
The video. I'm trying to watch this lesson over again.
Well, the video's not live.
I watch this in person in my brain.
Okay, get it?
No.
No? Got it now?
No.
How about now?
No.
Now?
Is that 10 of mine?
So that's 0.001, because 10 to the -4
Oh, it's 10 to the -4.
is, move it over, okay. 1, 2, 3, no, we started the 1. 1, 2, 3, 4. We need 1, 2, 3, 0. Hold it, please. You got like 10 seconds.
No.
Oh,
Oh, wow.
You just said no.
this is a funny.
Wait.
000. Oh no!
Wait,
It's
how is it?
How's what?
How is x
Yeah, stop.
999?
Because I subtract 1.
I'm stalling him.
When I subtract 1,
Oh.
too late, bye-bye.
Wait.
All right,
How many 9s were there?
Did you get that? There was 3.
ready?
Yeah. No, 4.
Watch. All we need to do is what? To get -0.999, -0.9999.
Why isn't it going up? Go up.
Just zoom, and it'll do it right. Okay? Because the default is 3 decimals, but if I zoom in far enough, it'll give me more decimals. Okay, that's the first boo-boo it makes. Some of you already saw the other boo-boo when you look at the other graph. Watch what happens when I go down.
Do that.
What happened? I don't know. Some engineering. It does keep going. There shouldn't be a hole there. That's just life. Okay? I don't know. I don't know what the programming is, but okay. All right. Okay, one more, and then we'll talk about translations. Okay, try this one. All real numbers.
Oh,
Come on now. So -infinity, positive infinity. Almost positive infinity. My domain starts at -2. -2 to infinity. And behavior is going to go like it normally does. So as it approaches -2, it's going down, right? This one's going down. And as it goes to positive infinity, it goes up. So you can see this, it doesn't change that much from one graph to another. A lot of things are going to be the same.
Yeah.
Asymptote, x equals -2. And then we're going to need a little help from Desmos for the other ones. Okay? So y equals log underscore, what was it, base 5, yeah?
Base 5.
5 of x plus 2.
Yep. -1.
Okay, so it crosses at -1 and 0.431.
431.
So -1, 0, and 0.43. 0, comma, 0.431, 431. Okay. You can put the graph over. I don't feel like it right now.
Oh, I didn't put any graphs.
Okay. The last few, these are all word translations where we're going to modify the equation. So take a moment, see what you can do with the first one. We'll go over it, and then I'll have you do the last two on your own. And that'll be it. Look at this first one. So you put your original equation in there. Y equals negative log underscore, come on now, underscore 9 for my base of x plus 4, and then we modify it. 4 units to the right. Does that mean I subtract or add onto the 4? Subtract. 4 minus 4 is 0, so I don't need anything else in there. In fact, I don't even need parentheses. Okay, 1 unit down, minus 1, and then vertically stretched. Oops, I need an equal sign over here. Okay. Vertically stretched. No, you're being recorded. Everybody now knows that Mr. Ramos needs his cuticles done.
Look, that one's all messed up.
So you want to put the?
Is there a camera? Look.
I have it closed.
Oh.
All right. So try the other two on your own. I'll put up the answers in a couple minutes. If you get done, then either complete the assignment from yesterday or start the next one. Or some of you, G of X. Okay. So if we're compressing by a half, what happens to the E? No, compressing, multiply. Goes down to 4. Okay, log underscore 7. Are we moving left or right? It looks like we're moving right, so we're going to need to add some parentheses. X minus 1, close it. We're moving up or down? Nope, so it sticks with the -5. And the last thing is reflecting. Put a negative way out front. Okay, next one. Give X, same idea. So it's being reflected across the x-axis, so I don't need the negative anymore. Log, my base is 10. It's a common logarithm. It's translating 5 units or 6 units to the left, so I need to add 6 more to this. So 11 minus x. Translated, vertically compressed by a factor of a third. Moving up or down?
No.
Just the original -2. Okay. And that, as they say, is that. Questions? Okay. So we've got 15 minutes.